What gets us into trouble is not what we don't know, it's what we know for sure that just ain't so. This is actually an important point, believe it or not, because there is another such assumption that a lot of people have in their minds right now about global warming that just ain't so. The assumption is something like this: the Earth is so big, we can't possibly have any lasting harmful impact on the Earth's environment. And maybe that was true at one time, but it's not anymore. And one of the reasons it's not true anymore is that the most vulnerable part of the Earth's ecological system is the atmosphere. Vulnerable because it's so thin. My friend, the late Carl Sagan, used to say, if you had a big globe with a coat of varnish on it, the thickness of that varnish relative to that globe is pretty much the same as the thickness of the Earth's atmosphere compared to the Earth itself. And it's thin enough that we are capable of changing its composition. That brings up the basic science of global warming, and I'm not going to spend a lot of time on this because you know it well. The sun's radiation comes in the form of light waves, and that heats up the Earth, and then some of the radiation that is absorbed and warms the Earth is re-radiated back into space in the form of infrared radiation. And some of the outgoing infrared radiation is trapped by this layer of atmosphere and held inside the atmosphere. And that's a good thing because it keeps the temperature of the Earth within certain boundaries, keeps it relatively constant and livable. But the problem is this thin layer of atmosphere is being thickened by all of the global warming pollution that's being put up there. And what that does is it thickens this layer of atmosphere. More of the outgoing infrared is trapped. And so the atmosphere heats up worldwide. That's global warming. This is the image that started me in my interest in this issue. And I saw it when I was a college student because I had a professor named Roger Revelle who was the first person to propose measuring carbon dioxide in the Earth's atmosphere. After the first 7, 8, 9 years, you could see the pattern that was developing. But I asked the question, why is it that it goes up and down once each year? And he explained that if you look at the land mass of the Earth, very little of it is south of the equator. The vast majority of it is north of the equator, and most of the vegetation is north of the equator. And so when the northern hemisphere is tilted toward the sun, as it is in our spring and summer, the leaves come out and they breathe in carbon dioxide and the amount in the atmosphere goes down. But when the northern hemisphere is tilted away from the sun, as it is in our fall and winter, the leaves fall and exhale carbon dioxide and the amount in the atmosphere goes back up again. And so it's as if the entire Earth, once each year, breathes in and out. So we started measuring carbon dioxide in 1958. And you can see that by the middle 60s, when he showed my class this image, it was already clear that it was going up. But the point of this is, all this time, you can see what I have seen all these years. It just keeps going up. It is relentless. And now we're beginning to see the impact in the real world. This is Mount Kilimanjaro more than 30 years ago and more recently. This is happening in Glacier National Park. I climbed to the top of this in 1998 with one of my daughters. Within 15 years, this will be the park formerly known as Glacier. Here is what's been happening year by year to the Columbia Glacier. It just retreats every single year. And it's a shame because these glaciers are so beautiful, but those who go up to see them, here's what they're seeing every day now. In the Himalayas, there's a particular problem because 40% of all the people in the world get their drinking water from rivers and spring systems that are fed more than half by the meltwater coming off the glaciers. And within this next half century, those 40% of the people on Earth are going to face a very serious shortage because of this melting. Italy, the Italian Alps, same site today. An old postcard from Switzerland. Throughout the Alps, we're seeing the same story. It's also true in South America. This is Peru 15 years ago, and the same glacier today. This is Argentina 20 years ago, same glacier today. 75 years ago in Patagonia, on the tip of South America, this vast expanse of ice is now gone.